Sludge Treatment Facility Operational Management. This lecture will allow you to learn about methods for operating sewage sludge treatment facilities. I will talk about sewage sludge generation and treatment routes, sludge treatment facility operation and management, ultimate disposal methods of sewage sludge, and ultimate disposal technology of sewage sludge in order. Sewage sludge generation and treatment route. First, I'll talk about the production and treatment route for sludge. In general, treatment processes at wastewater treatment plants are divided into water treatment processes and sludge treatment processes. In the primary and secondary sedimentation processes for water treatment, sludge is formed, and this sludge is first taken to a concentration basin to reduce its volume. The concentrated sludge is moved to an anaerobic digesting tank. When it is digested, gas is produced, and liquid sludge from the digestion tank is turned into solid sludge in a dehydrator and disposed of by incineration, in a landfill, or through decomposition. Sludge treatment facility operation and management. To operate a sludge treatment more efficiently, the following operational management factors should be considered. First, sufficient information on the volume of sludge conveyed from the conveyance facilities to inflow, and the characteristics of sludge should be shared. And the rate of discharge flow from the sludge pump should be checked. It is necessary to manage the process so that fibrous material does not adhere to the rotating blades of the small diameter pump. In addition, there is a risk of the sludge conveyance pipes being damaged by hydrogen emulsion, so they should be checked periodically, as well as cleaned periodically, such as through backwashing to avoid clogging due to contaminants, such as plastic or cloth. Of course, sludge must be conveyed, concentrated, and deutered before decomposition occurs. Secondly, concentration basins are divided into gravity concentration and mechanical concentration. In gravity concentration, the solid transit time is made sure to keep sludge from decomposing, and an arm sludge collector must be continuously operated. To produce an even sludge-liquid interface, solids balance must be evaluated, and sludge treatment factors must be constantly monitored to appropriately adjust sludge draw amount. During rainy weather, when sludge flow is expected to rise, the sludge-liquid interface in a gravity concentration basin should be lowered. And if the arm sludge collector malfunctions, inflow sludge should be conveyed to a different gravity concentration basin, and sludge in transit should be sent to a dehydrator or another gravity concentration basin. Next, in mechanical concentration, before sludge injection, water supply operation should be carried out to see whether there are any malfunctions. When the rotation speed of the concentration basin reaches the standard speed, attention should be paid to the water content of the concentrated sludge to make sure that the sludge amount slowly increases to the standard treatment amount. If possible, sludge supply should be even, without changes. And if the concentration basin malfunctions, sludge supply should be stopped, and sludge in the concentration basin should be withdrawn and washed. Finally, if there is high pressure in the concentration basin, the output pressure of withdrawal from the pump should be checked and adjusted as appropriate. Third, the properties of wastewater sludge that has already been injected and digested in the digestion tank, the properties inside the tank, the properties of supernatant, and the properties of the digestion gas should be periodically measured and monitored. Checks of gas pressure inside the tank and for leakage from the tank or gas piping system must be checked. And monitoring with thermometers, level gauges, and for the stirring status of mechanical or gas stirring are also important. Be aware of checks of the operational status of boiler room, equipment, and precautions during service. In particular, during mesophilic digestion, it is important to maintain a temperature in the digestion tank of 30 to 37 degrees Celsius, and during high-temperature operation, it is important to maintain a temperature of 50 to 55 degrees Celsius. Also, methanogenic bacteria inside the digestion tank are sensitive to changes in temperature, so caution must be used for temperature reductions over a long period. And care must be taken to keep the effective volume of the digestion tank from being reduced due to sedimentation. Inside the anaerobic digestion tank, an oxygen-free environment must be maintained, and sludge must be sufficiently stirred and mixed to increase digestion efficiency. Digestion temperature should be even throughout the tank, and it should be measured at multiple locations. In general, solids concentration in injected sludge must be maintained at 2 to 4%. Care should be taken to make sure that the solids content of injected sludge does not surpass 10% of the total solids in a single tank. Finally, an important element of management of a digestion tank is the maintenance of an appropriate pH level of around 6.4 to 7.2 in the anaerobic digestion reactor. For the most efficient digestion, the CN ratio should be kept at around 12 to 16 during operation. And attention should be paid to the thermometer in the primary tank so that the temperature doesn't fall below the measured value. The stirring apparatus should avoid intermittent operation and be operated continuously to avoid the formation of stagnant areas. And care should be taken to make sure the stirring blades are not overloaded due to tangling from fibrous material. In particular, digestion gas can explode due to exposure to an ignition source like an electric spark, so caution must be used. Careful checks must be made to avoid malfunctions, such as corrosion, cracks, or defective joints, and to avoid gas leakage or mixing of air. The fourth and final process carried out in a sludge treatment facility is dewattering. First, changes in sludge and flow volume to the dehydrator affect dewattering efficiency, so it should be operating without changes in volume. Chemical dose should be chosen with consideration to the water content of the sludge and the dehydrating characteristics of the dewatterer. Once operation stabilizes, attention must be paid to the amount of inflow sludge, chemical dose, and the properties of the dewattering filtrate. During operation, it is necessary to pay attention to operational indicators, such as the readings of the pressure meter and ammeter, noise and vibration, the amount of dehydrated sludge and chemical dose, and dewattering speed, etc., to make sure there are no large changes. In particular, if chemical dose or dewattering conditions are adjusted, various tests must be carried out to find the optimal operational conditions. The main types of dewattering equipment are belt press centrifugal separation and multi-disc dehydrators. First, belt press equipment produces sludge with a consistent concentration, and attention must be paid to make sure an appropriate flocculant dose is injected into the best press. It is necessary to supply sludge and flocculant dose consistently at the optimal ratio. It is necessary to check to see whether unusual noises are produced by the filter cloth or flocculant mixer, etc., and to check to make sure the spray nozzle for filter washing isn't clogged and that inflow pressure is normal. Also, a backup filter cloth must always be ready as a measure against increasingly frequent filter cloth clogging and decreased filtration rate. Next, let's look at the operational management of a centrifugal separation dewattering device. Since centrifugal separation dewattering uses high-speed mechanical rotation, sufficient attention must be paid to lubrication and vibration in the drive part. If changes to the dewattering situation occur, reduce sludge inflow and evaluate the dewattering situation. In particular, centrifugal separation dewatterers use a low chemical dose, so pay attention to the instrument panel of the flow meter and check to make sure that the chemical dose is appropriate. In addition, matter from sludge may accumulate inside the dewatterer, so attention must be paid. Finally, let's look at the operational management of a multi-disc dehydrator. First, it must be made sure that the properties of the sludge are consistent in the flocculant mixing tank before the sludge is provided to the dehydrator. It is necessary to carefully check for loosened bolts, the condition of joints, abnormal vibration, and the rotation direction and load of the reducer pump and agitator, etc. It is also important to check for leaks from piping connections and to check the amount of lubricating oil and for damage to the electrical components, as well as for the presence of foreign substances inside the dehydrator itself of the coagulation tank. Ultimate disposal method of sewage sludge. Finally, we'll look at methods for wastewater sludge disposal. As I explained earlier, the sludge cakes discharged from a deuterator in a wastewater treatment plant can be disposed of in four main ways. First, sludge cakes can be solidified as used as cover material near landfills. Next, they can be decomposed and used as compost in agricultural areas. Or if there is an incineration plant nearby, they can be incinerated. Lastly, sludge cakes can be dried and used as fuel for thermal power plant, or as auxiliary fuel or raw material by a cement company. The final disposal of wastewater sludge is be promoted through the application of a variety of technology to turn it into a resource, depending on regional characteristics. Ultimate disposal technology of sewage sludge. Now I'll explain final disposal of wastewater sludge in a bit more detail. First, there's solidification treatment. Deutered cake is combined with a solidification agent, a component of cement, then dry cured, and usually used as a covering material for landfills. This causes little environmental pollution and is advantageous for areas with large-scale landfills. But the disadvantages of this method are that its reduction rate is low, and it is used near landfills because there are few areas in which it can be reused. An additional disadvantage is that the drying process requires considerable fuel. Second, we have decomposition treatment. This refers to a technology in which uses pre- and post-fermentation under aerobic conditions is used to produce stable compost. Advantages of this method are that environmental pollution and cost are low. But it has the disadvantages that due to the addition of sawdust, its reduction rate is low, and if it contains heavy metals, it is difficult to find a consumer. Another disadvantage is that this method requires a large area. The compost is used in managed forests, green space, slope reforestation, and various flower complexes. Third, I'll describe incineration. This refers to a technology in which, after sludge is deuterated, the combustible elements are burned in an incinerator, and stable waste is produced in the form of incineration ash. It has a high reduction rate, and there are many examples of its use in Korea, so it is highly technically reliable. However, it leads to the most civil complaints due to the incineration process, and it creates the need for large-scale environmental pollution prevention facilities to solve this problem. Operational technology for this method is relatively difficult. The material produced is put in a landfill or used as raw material for cement. The fourth method is drying. Because only drying is used to lower the water content of the deutered cake, the treatment process is simple and easy to manage. This makes it highly technically reliable. However, fuel consumption for the drying process is high, or there is a risk of civil complaints due to odors. The reduction rate is lower than in incineration. The treatment byproducts are used as a raw material for cement, fuel for kilns, and soil improver. Finally, there is carbonization. This refers to a technology in which deutered cake is dried, then goes through thermal decomposition in a carbonizer in an oxygen-free environment. This method offers an excellent reduction rate and a wider variety of areas for reuse than other methods, in addition to which waste heat produced by the drying process can be used as a heat source. However, it has the disadvantages that if it is used as soil improver or manure, when it has high salinity, it can affect soil and crops, so its use is limited. Another disadvantage is that because carbide itself is not completely decomposed, its properties are unstable. This concludes my presentation of the operational management of sludge treatment facilities. Thank you for your attention. I hope you found it helpful.